Okay, so far we have learned about ionic bonds, which happen between metals and nonmetals when electrons are transferred. We have learned about metallic bonds, which happens between metals, and it's when you have that sea of electrons or the electrons are like shared between many different metal cations. And today we're going to be focusing specifically on those covalent bonds, which happen between nonmetals. So you can kind of look at the word covalent and kind of like understand what this means. So co means sharing, just like if you cohabitate with somebody, you share a habitat or you live with them. So covalent compounds are compounds that share their valence electrons. And so they happen between nonmetals. Remember, those electrons are shared specifically just between like two atoms, or sometimes you might have a few more atoms that are sharing electrons. And this is where the term molecule comes from. So when you have a compound that's made of covalent bonds, we call that a molecule. So we don't just form, we can form single bonds if each element is just contributing one electron to share a pair, but you can also have double bonds if each one is sharing two electrons, and you can also have triple bonds if they're each sharing three electrons. So it's just however many electrons that element needs to achieve its octet or to get 8 valence electrons, that's how many it's going to share. So you can see like oxygen's in group 6, so it has 6 electrons. So it is going to need to share 2 more electrons with another oxygen atom to get to 8. And so you might have seen like pictures of molecules before where they have like double lines or triple lines, and that's just telling you it's a double or a triple bond. We're not going to get too much into that for this course, but I just want you to know that they do exist. Elements can share more than one electron with another atom. They can share multiple electrons. And so when they share their electrons, they don't always share them evenly. Like the electron cloud density isn't always just right in the middle of those two atoms. If you have a polar covalent bond, so think of a like polar, I mean, yeah, you might think of cold, but typically something that's polar, it has like poles, or it has like a negative and a positive region. So like think of like a magnet or something, or like the North Pole and the South Pole. They're two opposite ends. And so when you have a polar covalent bond, one of the atoms like hogs those electrons a little bit more, so that electron cloud is going to be more dense over the more we call it electronegative atom. And if something's electronegative, it just means it has a greater tendency to attract electrons to it. So in this example, we've got chlorine and hydrogen. Chlorine has a much higher electronegativity. So even though chlorine sharing an electron and hydrogen sharing an electron, that overall like the electron density is going to be closer to the chlorine, just because the chlorine almost acts like a little like magnet and pulls the electrons in closer to it. So because the electrons are shifted more to one side of the molecule, that side of the molecule is going to be a little bit more negative. And then the other side that has like more of an absence of electrons, it's going to be a little bit more positive. So this isn't a full-on ionic bond with anions and cations, but you do have slightly more negative and positive regions, similar to an ionic bond. On the other hand, if the elements have a really similar electronegativity, or if they're the same element and they have the same electronegativity, then it's going to be a nonpolar covalent bond, because now the electron cloud is like evenly dispersed throughout the molecule, because the not one like one of those atoms doesn't have a stronger tendency to pull the electrons closer to it. So it's going to be nonpolar, no poles, like no real positive or negative regions. And so if you look at this, it's talking about the bond polarity. And so the electronegativity differences, let me see if I can get my little, you can see right here, the electronegativity difference. So if it's a difference in electronegativity between two atoms, and if it's somewhere in the 0 to 0.4 range, then that means it's going to be a nonpolar covalent bond. The electronegativities are pretty similar, or there's no difference at all. And so you can see this electron cloud, like the molecule, you've got your two atoms, and it's pretty evenly dispersed. Next, if the difference in electronegativity, so you're just subtracting the two, if it's between 0.5 and 1.8, you're going to get a polar covalent compound, and that's going to create a more negative region where the electron cloud density is higher, and then a positive region where the electron cloud density is much lower and it's going to be a little bit more positive. So that's if you have a difference in electronegativities between 0.5 and 1.8. And then finally, we have ionic, which we already talked about, but that's going to be if you have an electronegativity difference greater than 1.9, where you literally have a straight up positive cation and negative anion. this periodic table here is showing us the electronegativity values. It ranges anywhere from like really, really low, like you can see, for example, like francium is 0.7 to 4. So fluorine is the most electronegative element, and it has an electronegativity of 4. There is no unit with electronegativity. It's just a number. So if we're looking at a bond here between our first one, we have carbon and hydrogen. So carbon has an electronegativity of 2.5. Hydrogen has an electronegativity of 2.1. So we just subtract, we just find the difference. So 2.5 minus 2.1 gives us 0.4. So that means it's going to be a non-polar covalent bond because 0 to 0.4, if you look at that little diagram on the bottom, gives us non-polar covalent. So if there's a bond between carbon and hydrogen, they're going to share their electrons pretty evenly. You're not going to get a strong positive or negative region. Let's try oxygen right here, and we already looked at hydrogen. So hydrogen is 2.1, oxygen is 3.5, so that's an electronegativity difference of 1.4. That's going to fall under the polar covalent because it falls in the 0.5 to 1.8 region or range. So that is just going to be polar covalent. Let's try another one. So we've got carbon and fluorine. So carbon we already worked with, but it's over here. Fluorine is right here. So if we're going 2.5 and 4, just subtract the difference. So 4 minus 2.5 is going to give us 1.5. That still falls under the polar covalent range. Remember, polar covalent is 0.5 to 1.8. And then we'll do this last one where we have carbon, which we've been working with consistently, and this time bromine. So we have 2.5 to 2.8. Find the difference there. It's just 0.3. So this one is non-polar covalent. So looking at this chart of electronegativities and finding the difference in electronegativity between these two atoms that are forming a covalent bond will help you determine if it's a polar covalent bond or non-polar. Next, when you name covalent compounds, you do it the same way as ionic, like the first element keeps its name and the second element gets an "ide" ending. The only difference is you have to use prefixes, and the prefixes tell you how many atoms there are. If you have one atom, it's mono, but we don't usually use the mono prefix. Every once in a while we do, like for example, like carbon monoxide, but mono is typically left off, so you don't need to include mono in your naming. So looking here, N is nitrogen. The first element keeps its name. And hydrogen turns into hydride because it still gets the "ide" ending, but there's 3 hydrogens, so it would be trihydride. H2O of water. The chemical, official name of water would be, there's 2 hydrogens, so you have to put the prefix goes before. It would be dihydrogen. And you can just say oxide if you want. If you want to include the mono prefix, you can. One thing to note about those, oops, what did I do here? So if you wanted to write, oh my gosh, cannot do this today. If you're using that prefix, a lot of times if it's like 2 soft vowel sounds in a row, like you wouldn't say monoxide, you would drop one of those O's and just say monoxide. So same thing with like penta, you wouldn't say pentaoxide, you would just say pentoxide. Looking at CO2, you probably recognize this. There's only 1 carbon, so we'll just write carbon. And there's 2 oxygens, so that would be dioxide. And then our last one, Si, is silicon. And there are 4 fluorines, so that would be tetrafluoride. So that's it. You're going to finish up this co-formative assignment and let me know if you have any questions.